One of the most common operations in woodworking is the dado. This cut's frequently used in basic cabinet making because it provides greater glue surface when putting two pieces of wood together than just a simple butt joint. They're frequently used in partitions in the casework of a cabinet or for positioning fixed shelves in a bookcase. Now, the size of any dado cut is determined by the dimension of the piece of material that it has to accommodate. And whether you're using solid lumber that you mill yourself or pre-manufactured sheet goods like plywood or composite board, you'll find that these materials are frequently off-sized and usually undersized. Now, using the microfence edge guide and a simple two-cut approach, we can accommodate any size material by measurement. We can even measure the amount of clearance or tolerance we want to include. Well, talk is cheap. I think it's time we showed you how it works. Now, first we need to measure the material that we want the dado to fit. This piece of 3/4 inch material should measure 750 thousandths. Now, if we look on our equivalency chart that comes with every one of our units, we'll see the equivalent of 3/4 is 750. Now, don't worry if you're not fluent in decimalese, because each microfence does come with an equivalency chart. Now, our plywood actually measures 708 thousandths. It's really undersized. Now, since there's no bit that cuts that dimension straight away, our only choice is to use a smaller bit and make two passes. We'll use the microfence to measure in between cuts. Now, before I go any further, I'm going to jot down that 708 so I don't have a senior moment and forget it. Now, we have a 5/8 inch bit installed in our router here. Now, that's smaller than 3/4, and we can use that for our first cut. But before we go any farther, let's set our fence on an even number just to make the arithmetic simple between our cuts. Now, we have 50 thousandths per turn on our dial, and 50 on the microfence dial is the same as 0. So we'll set it there, and we're ready to make our first cut. Now, this cut should measure 5/8 of an inch. Now, if we check our chart again, we'll see that the equivalent of 5/8 is 625. Now, as if we didn't have enough problems with the materials being off-sized, experience has taught me that router bits don't necessarily cut to size either. Now, more often than not, they'll cut some other size than you'd expect. There's also an issue of collets in routers running out, and if your bit's been sharpened, it certainly won't be cutting to full size. So let's measure the cut. We find, using our calipers again, that we actually just cut 602 thousandths, not the full 5/8 of an inch that we thought it would. So, by subtracting the 602 that the bit just cut from the size of our material we want to accommodate, we find we have to move the fence 106 thousandths. The microfence dial is graduated in thousandths, and each turn gives us 50 thousandths. So we'll go once around for 50. A second turn will make it 100. And we'll add 6 to get to our dimension of our material. Now, I want a little bit of clearance or tolerance, so I'm going to put in 3 or 4 thousandths, lock it down, and we're ready to go for our final cut. Now, here's the kind of joinery you can expect every time you use the microfence. Now, I'd like to show you one other example. Let's go to the other bench.